Hello everyone. Today we'll be going through section 4.1 of Pure Math 2. We'll be learning about the product rule, where you can apply it, and we'll also be learning about how to prove the product rule using the first principles of differentiation you would have learned in Pure Math 1, followed by a quick example of the product rule in use. Now the product rule is used to differentiate functions which in and of themselves are a product of two separate functions. So we'll consider a function y is equal to f of x times g of x. You can consider f of x to be equal to u and g of x to be equal to w if that's something that makes you feel more comfortable. An example of this could be y is equal to, open brackets, 4 minus x, close brackets cubed. So this would be f of x, in this case, multiplied by, open brackets, 7 times x to the power of 4, plus 2 over x squared, close brackets. And the second part right here would be g of x. Now, you could multiply this whole thing out, and you get one very long polynomial, which you could use the power rule to differentiate. But it is much faster to just use the product rule on this initial function right here. And for the product rule itself, here it is. We have that y prime, or the derivative of y, with respect to x, is going to be equal to f of x times the derivative of g of x, g prime of x, plus g of x times f prime of x. So, with reference to this function, it would be this first function multiplied by the derivative of the second function, plus the second function multiplied by the derivative of the first function. Now, using a slightly different notation, if we're considering f of x to be equal to u and g of x to be equal to w, you can instead consider this as dy over dx, the derivative of y with respect to x, is equal to u times dw over dx plus w times du over dx. You can see it's the same thing. One function times the derivative of the other plus other function times derivative of the first function. Now from here, we want to know how we actually get to this result. And we'll prove this by the first principles of differentiation. So the first thing that we'll consider is we'll actually consider our example of y is equal to u times w, where u is equal to f of x and w is equal to g of x. Now, when we're proving a derivative by first principles, we need to consider a small change in the value of x for our graph, which we'll call delta x. And we'll consider what happens as the small change in x approaches 0. We'll consider the limit as delta x approaches 0. Now, what we have to note is that when we have a small increase in x for our graph, we will have a corresponding small increase in y, small increase in u, and a small increase in w. So in order to represent a small increase in x, we will write out y plus by delta y is equal to u plus delta u multiplied by w plus delta w. Now, the first thing we're going to want to do here is we're going to want to multiply out these brackets. So let's consider y plus delta y is going to be equal to u times w plus w times delta u. Oh, I miswrote that, but that also works. U times delta w plus w times delta u and plus delta u times delta w. Next up, we can consider the fact that uw over here is equal to y. We can substitute that into the equation and then subtract y from both sides, and what we end up with would be y minus by y plus delta y is equal to uw, which is y, minus by y, plus all of this, which we are just going to write as lambda, because I am a little bit lazy, plus by lambda, which is just all of these terms together, And then what we end up with is delta y is equal to our lambda. Now, from this point forward, we want our derivative notation, which of course is dy divided by dx. So what we're going to do here is we're going to divide both sides of this equation by delta x. So delta y divided by delta x is going to be equal to, and now I actually have to write this out, I'm going to have u multiplied by delta w over delta x, and I'm sure you can see where this is going. We're going to have something very similar to the product rule, just with an extra term added. We're going to see what happens to that extra term. Plus w times delta u over delta x plus, and now we're going to have delta u times delta w over delta x. Now, when we consider that delta x is approaching the value of 0, we know that delta y must also approach 0, delta u must approach 0, and delta w must also approach 0. And from this perspective, we're going to take this equation and we're going to consider what happens as delta x approaches 0. Now, from our first principles of differentiation, we know that delta y over delta x is going to become our derivative, dy over dx. And then this is going to be equal to u multiplied by, this would become dw over dx, plus by, and we would have w multiplied by du over dx. And then we have a bit of a problematic final term here. And there are two different ways that you can interpret this. Either you can consider that since delta u and delta w are both approaching 0, delta u multiplied by delta w will be very, very small in relation to delta u on its own or delta w on its own either. And because of that, we can consider the value of delta u times delta w as they both approach 0 to be essentially negligible, and this entire thing is equal to 0 as x approaches 0, and it completely cancels out of the equation. That's one way to interpret it. Or you can simply consider this as delta of one function multiplied by the derivative of the other function, so you could consider this as being delta u times dw over dx. But what happens to delta u as x approaches 0? Delta u approaches 0 as well, so we end up with 0 multiplied by dw over dx, and 0 multiplied by anything is just 0. So this cancels out regardless. And of course, you could flip this around. You could have delta w times delta u over delta x. Then you would have delta w approaching 0 multiplied by du over dx. So you would once again have 0 times the derivative of something, and 0 multiplied by anything is just 0. You can see, with this cancelling out, you end up with the simplified form, u times dw over dx plus w times du over dx. And there we have it. Now I would like to do an example, and for this example I would like to consider the original function that we were looking at the beginning of the video. Y is equal to 4 minus x cubed times 7x to the power of 4 plus 2 over x squared. We're going to apply the product rule here to find y prime, or dy over dx. So y prime is going to be equal to the derivative of one function multiplied by the other function. So let's start with the derivative of 4 minus x cubed. First thing that we have to do is we have to find the derivative of the inside, which is going to be negative 1. The derivative of 4 minus x is negative 1. This is going to be multiplied by. I'm going to do the derivative of the outer function now, so the chain rule, multiplied by 3 times 4 minus x, and the power reduces by 1 squared. Then this will be multiplied by the other function, 7x to the power of 4, plus 2 divided by x squared. Now we're going to do the derivative of the second function multiplied by the first function. We're going to have derivative of 7x to the power of 4, which is going to be 7 times 4 times x cubed. 7 times 4 is 28, times x cubed, power reduces by 1. And then here we have 2 times x to the negative 2. So we'll have 2 multiplied by negative 2, which is negative 4. And then the power reduces by 1, so we end up with x to the power of negative 3. So we have x cubed in our denominator here. And then we are just going to multiply by our other function itself, 4 minus by x cubed. There we go. That's our derivative. Now, we can apply this just for a quick example. Why don't we find the derivative when x is equal to 1? So we're going to find y prime of 1. This is going to be equal to, well, we're finding the gradient of this function when x is equal to 1. This is going to be equal to negative 3 times 4 minus 1 squared times 7 plus 2. And then you're going to add 28 minus 4 multiplied by 4 minus by 1 cubed. Now, of course, 4 minus by 1 squared is 3 squared, that's 9. Negative 3 times 9 is going to be negative 27. And then you're going to have negative 27 multiplied by 7 plus 2. 7 plus 2 is equal to 9. Negative 27 times 9 is equal to negative 243. I miswrote there. Negative 243. And then you're going to add 28 minus 4. 24 multiplied by 3 cubed. That would be 24 multiplied by 27. And 24 multiplied by 27 is going to be 648. And then this works out to be equal to 405. So the value of the gradient of this function when x is equal to 1 is going to be 405.